Hello and welcome, and once again, welcome to all the new people because it seems like there are more of you than usual, uh, as indicated by the large number of comments on my last video saying, "What the fuck is this?" Um, yeah, this isn't for everyone. Definitely niche content over here. So I'm going to show you an attempt at the semifinals case from the XL World Championship 2025. This one's called Mahjong Solitaire, and the idea of the game is based on the real game. I don't know how closely because I have not played the real game, but you have kind of rows of tiles like this. Um, each row is its own game, and so you can, if there's a matching pair of tiles at the edge like this, you can take them off. And then later we get into more kind of two-dimensional games. So like you can match this with this. Um, these match? No. Oh, sorry. The highlighting is the open tiles. So you can only match tiles that are at the edges. So here you can take those off, and then once those are revealed, there's the season cards match each other, or flowers, or whatever. I think these are flowers. Anyway, whatever they are, they match each other. So those can both come off, and these match each other. So those can both come off, and so on down. And you work your way down until there's no more tiles that you can remove. So all the open tiles are different from each other. And then in the last level, if we get there, let's see, it's like this. So you've got a second layer placed on top of the first, which means that anything that is covered up is not open. So you have to be you have to have either on your left or your right no tile in the same level as you. So is there? I don't think there's an illustration of a level 7 game partway through. But so, for example, if you took this tile away, then the tile beneath it would become open, but also this tile to the right of it would become open. Because there is a tile to the left of this on the lower layer, but not on its own layer. So, yeah, that's the idea. So we've got tiles here, the tile character, the Unicode, the category, the name, and the count. Count? I don't know what that's for. Oh, got it. All right, never mind. Don't worry about that. All right, so yeah, I'm going to start my timer and dive on in. I'm going to start with the bonuses because that's what I would have done in the final. I should clarify, this is not going to be a live. I was hoping to do a live solve recording, but then I ended up I watched the game live and got a chance to mull over it a bunch, and then also I was doing a training with the full stack modeler crew yesterday and was asked to have a look at this one. So I have now played this before. Anyway, okay, there's one tile that never appeared in any of the 140 games, provide its Unicode number, and there's one tile that appeared more frequently than any other. How many times? So to do that, we're just going to add a I don't know, occurrences count here. And for that, first I'm going to vstack all the tile blobs together. So we get this, 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 this. Not that. We're excluding the examples. Take all of that. I'm including the blank column. Take all of that, and I think we got one more level to go. Yes. So that gives me a big stack, and it gives me errors where, some of the ones down below are wider, so the whole array returned is wider, but there's nothing here, so those become errors, but that's fine. So then we can use toCall with the third argument, which will ignore errors and blanks, and that will return just the tiles. And then I'm going to say let, I don't know, used be that, and then what I want is group by used rows 0, 0. And that'll show me all the tiles and how often they're used. And then we can VLOOKUP this into that, returning from column 2 exact match. I have not, but I have put these in the wrong place. And if error 0. So we'll pop that in there and then expand our filter over to here. So we want the least frequent one, I think we want the Unicode for. And for the most frequent, we want the count, which is going to be the max of this column, which is 127. I guess I'll do it by formula. Okay. Actually, I'm not going to leave that as it is because I'm going to Copy value, paste this in a second because I want to turn this into a table, and the spilled formula won't work for a table. So let's do that now. We'll turn that into a table name T, because I always go with short table names to keep it simple. And yeah, that is now refed out. We'll just go with T occurrences. All right, to the right of this question, we've encoded a 10-letter phrase. I wish to you each letter is encoded with a Mahjong tile. Use the first letter of each tile's name. See column E in the tiles tab. So we're going to concat the first letter of XLOOKUP these tiles in T tiles, returning from T name. Not too fast. And then this depends on the levels, and this one, each tile that belongs to the circles category has the corresponding number of smaller circles on it from 1 to 9. How many of these smaller circles are there on the tiles featured in the 140 games of the case? Okay, so let's go to circles. And they're listed in ascending order, so we can just say sum of these numbers here times sequence 9. Bring that over here and in here. Okay, so now let's get into the levels. Oh, and actually, sorry, because I have these numbers here written in order, I'm gonna bring them over here, because for this level, you have to look each of these up, and each of them corresponds to a number, and you have to sum the numbers, but you're not given the numbers in text anywhere as a handy table, so I just grab that from there, just name that nums. So then this should be sum of XLOOKUP, sorry, yeah, sum of XMatch. So we're going to look this up in T tiles, returning from T name, I think is where the number is, and then we're going to match that against nums and sum them. Happy days. Okay. Level 2, you're given a set of 12 tiles. Find the Unicode numbers corresponding to these symbols. So you can either do sum of Unicode of this, or you can do sum of XLOOKUP this in T tile, returning from T Unicode. Same answer in both cases. All right, so that's the kind of start, and then from here on, it's just solving the game with different complexities added. So at this point, I'm going to take a quick pause and introduce you to my table picker function. I've been using XLOOKUPs, but this will make it simpler. So if I have, let's say, a couple of tiles here, then so when I did the table setup, that wasn't the native Excel table setup. That was a robot command that hijacks Control T. And in addition to setting up the table, it sets up a picker function. So I can say, I want to pick these two. Oh, sorry, I got to import my lambdas as well because it uses one of my lambdas. There we go. So I can pick the rows corresponding to these things, or I can say I'm interested in column 3, which is the category, or I can say I'm interested in the column named name or whatever. It just makes it easy to look things up. And by default, it looks for whatever I give it as the row slice in here, because this is the column that I was in when I called the command. So nothing that you can't do with XLOOKUPs and filters, just a quicker way to set things up. Okay, so so here we just have one row. We kind of take out matching tiles until we don't have matching tiles anymore. There's a bunch of stuff that you could do for this level that would solve this level pretty quickly, but wouldn't scale terribly well. I want to set something up that I think is going to work later. I'm actually slightly tempted. No, I'm slightly tempted to just go and solve level 7 in a way that I can then like reverse scale back to the earlier levels, but I'm not going to do that because I feel like that is not that's not an authentic way to solve a case that had 5-minute eliminations where you need to be watching your back and scoring points as you can. So let's not do that, but let's do this. I want to write a lambda that will take in a board that will figure out what can be eliminated, that will eliminate it, and then return the board. But because there are things that are like on top of each other and next to each other later, I want to do it without moving. So I think the natural way to do this would be to say if the ends are equal, then drop both of the ends and just return a 10 character array, where I want to keep the size the same. That's going to be part of the aim. So having said that, let's take all of this. We'll just paste that there, mark as input for my robot command. I'll call this tiles, then what I want to figure out is it open? But again, I want to do something that will potentially scale to level 7, because for level 7, where there are stacked tiles, I'm going to put the top tile first and then the tile underneath second, something like this. And so I want to do something that considers openness, factoring that in. So what I'm going to do is I'm going to take the lengths of these. Now you'll notice those are all 2, even though it's only one character. Just a good sense check is to check the length of all of them, and the answer is they're all 2s. Minimax is 2. So you can, if you want, and if you have a new enough version, go to Formulas, Calculation Options, and change to the latest compatibility version. And that's a little smarter about Unicode characters. So now the length of all of these are 1. But you don't really have to, because the way that I'm going to use this, all that matters is change. So in other words, if I were to say delete these, then these become zeros. So the key thing is that if at least one of your neighbors is smaller than you, then you are an open tile. Otherwise, you're not. So we're going to say, we are going to say prev of this fill with 0. So that's going to give me the previous value. So again, if I were to have a 2 in here, then from this position, the previous value is a 2. So what I want to say is prev of that is less than that, or the next one, which I do is nxt of that is less than that. That didn't work. Sorry, nxt of that and 0, fill with 0. So now I'm getting 1s at both my ends. That's what's open. So I'm going to call this length. I'm going to call this is open. Then I'm going to do open tiles. And for that, I'm going to say to call ifs this, then this 3. And that is going to give me a list of tiles that are open. And the reason for the ifs is because ifs will say this condition, if that's true, then give me this. Otherwise, I'm expecting more conditions. And if you don't give it the right number of conditions, it returns an error, which is NA. And toCal can just ignore that. So it flattens it, but also drops the errors. And that's it. Oh, except that I also want to do left of this, because again, in the case where I've got stacks, I only want the first one to come out. So then I'm going to call this group, and we're going to say group by open tiles, rows 0, 0. And that's going to tell me I have 2 of this tile. And later, if we get into this is 2-dimensional and it's bigger. Actually, sorry, I'm just realizing as I say 2-dimensional, my prev and next are only set up to work on single arrays, so I have to use shift actually. So shift by 1 column and fill with 0. Oops. And then take that, put it over here, and shift by -1 column. Okay, now we're good. Okay, then I want to, I guess, clean. I'm going to reduce my initial array through sequence of rows of my group by. I'm going to say lambda a v, and what's it going to be? It's going to be if is open. Sorry, keep referring to it here because I'm going to make it a robot command. So if is open, then we're going to substitute from a. We're going to say index. Oh, sorry. If is open times index of this row v column 2 has to be greater than 1. Put that in brackets. So in other words, for each row in this group by, because there could be some single open tiles, there could be pairs of open tiles. For each row in this group by, we're going to say if you've got more than one of that tile, then substitute in the if you've got multiples, and if you're in an open slot, meaning these two at the edges, then we're going to substitute index of this. The row number is going to be v, and the column number is going to be 1. Substitute that to blank and replace only instance number 1, because that'll help to deal with the multiples later. Sorry, and then, so that's if you have a hit, and otherwise just return the array itself. And that's it. So now this applies one step, and now I need to kind of save that as a lambda and then apply that as many times as I need to, and then we'll be getting somewhere. So we'll save lambda as, I'll just save lambda, and that all seems to be behaving as I want it to, so I'm going to say OK, and I'm going to call this one step. Oh, and actually, sorry, edit lambda immediately, because the other thing that I want to do is add an unused optional second argument, because that will allow me to use it in a reduce. So now, hopefully, I can say reduce this sequence 6 one step. And sure enough, that goes until there's not any more to take away. And then the question is the Unicode values of what's left. I don't know what Unicode is going to do with the spaces. It's going to give errors. Okay, so then we can say sum of if error Unicode 0. And I think that's working. Let's drop it in and see. No, immediately not working. Oh, because it's pointing to actual cells here. Oh, sorry. I just pointed it to the wrong place. My bad, my bad. Should be pointing to here. Okay. There we go. Okay, level 4. Okay, same layout as on level 3, but now we're using all the possible tiles, and the extra twist is flowers and seasons are different. So we have to think about how we do open tiles differently. So I'm going to add a thing called group, and the group, why is that? Behave yourself. So the group for most tiles is going to be the tile, but for flowers and seasons, so the idea is any of these can be paired with each other. So I'll just call that F, and I'll call this S. So now, what I want to do, let's bump this over a little. I want to group by the groups. And that doesn't change a darn thing there, but for the other one it will. So now I think what I want is, well, let's just grab a couple of seasons, flowers, something. Yes, these will do. So let's just take this and put it up here. Oops. Okay, so now, yes, it's telling me these are my open tiles, but that groups into 2 flowers. But now I also need to know what those flowers are, because I need to be able to substitute. Do I? Yes, I need to be able to substitute them out. I could just say, if the type is flower and the tile is open and there is a flower group, then get rid of it. But I want to be able to do something that will still work when there's 2 layers. So I think I'm not going to do that. But let's do this. Let's do hstack of rows and concat. And let's do drop the first row of that. Okay, so now we've got, oh, sorry. Yes, so for the second one, I want the tile itself, not the tile group. Okay, there we go. So now we're saying flower is the group, there are 2 flowers, and these are the 2 flowers. Good. So, bother, I've lost the last step here because I generated instead of copying somewhere else. Okay, so my last step was this. So in order to reduce tiles, sequence rows of group, if is open is here, and index group. Okay, So now the extra twist is, let's see, the Unicodes of all of these are gigantic numbers, right? 120,000. Yeah, okay, fine. So I can test if this is, if the Unicode of this is like less than 100, say, then that means we're doing one of these things. So, oh God, it's going to be another layer of reduce nested inside here, which is kind of messy, but okay, fine. So we're going to say this is my one. So we're going to say if Unicode of, no, not Unicode of the first character is, let's say, less than 1,000, meaning we've got a letter. Well, let's say it's greater than 1,000, meaning we don't have a letter, then we can just keep this bit the same. Otherwise, we need to do some mad stuff. And then close bracket, and then back to that's the otherwise A. Okay, so then it's going to be reduce A through letters of index of this V3. So in other words, indexing this for whatever row number we're in, and the third one is going to give us the list of tiles. Letters is going to split that into letters, and then it's going to be substitute a, then I need a lambda. I guess I better not call it A and V again. Lambda acval, and it's going to substitute acval blank 1. That's the end of the lambda. No, that's the end of the substitute. That's the end of the lambda. That's the end of the reduce. I don't need that one. Something's not right. Okay, so an if here. That's option 1. That's option 2. That looks fine. Ah, okay. Yeah, then you need to close the if. Then we're back to the outer if. Okay, cool. Whew. So then we'll save lambda as. I'll call that, I don't know, I guess I'll call it 1 step plus because it has the seasons as well. 1 step plus. Okay. Whew. So now I think we can just do this to here, but with 1 step plus. No, totally doesn't work. Bother. Oh, because it errors out. Okay. So let's just do 1 step plus of this. That works. Okay. Then let's do 1 step plus of this. Works, works, works. So it must error out at the end again. No, it works absolutely fine. So what's the problem? Reduce that sequence 1 step plus. Oh, hang on. I bet I know what it is. I bet I know what it is. Wait, that looks weird, but not what I was expecting. 1 step plus, did I add the second optional argument? I bet I didn't. Ugh. Fine. Optional unused second argument. Save lambda. Ah, there we go. Now we're back in action. Right. So it would almost certainly not have been a winning strategy on the day to go this deep before going wide. But anyway, so hopefully we now have something that actually will generalize to the next level. So we just need to, our starting point needs to be vstack of this and this. And I guess we might now need to go up to 12 steps. Ah, there we go. Now it's paying some dividends. Okay, level 6. What changes in level 6? I think it's just more tiles. So then, yeah, hopefully we can do this again. And now the setup for level 6 is 4 layers of 12. So we should just be able to say, replace this vstack with wrap rows of this by 12s. Oh, look at that. Awesome. Ah, one of them is wrong. Oh, I bet I'm not going enough steps because now there's 48, so you might need to go up to 24 steps. There we go. Better. Okay, I'm re-recording my finish for level 7 because I made a stupid mistake here. So there's a kind of tricky little bit of generalization for a nuance in level 7, which we'll come to in a minute. But then there's also a separate thing, which is like I mentioned, the way that I'm planning on modeling this is to have the array look something like this, and then just handle it as a single blob. But when I got, let's say we, delete a few things here. When I got to my end array and tried to score it, I did, the sum of the Unicodes like I had done on the earlier levels. But if you take Unicode of 2 characters, it only returns the Unicode of the first character, just like if you say, char of ABC, it just returns, sorry, code of ABC, I mean. It just returns 65, which is the code of A. It only acts on the first character. And so I was only getting the Unicode for the sort of visible layer instead of everything. So that was a silly mistake, and it meant that I spent a bunch of time in debugging hell. So not going to make you watch that. Anyway, the nuance that we do have to deal with here is that now there might be 3 open season or flower tiles. So there's only ever whatever of this green bird. There's only ever either there's a pair or there's not. But because there's 4 seasons and 4 flowers, if you end up with 4 of them exposed, that's fine. You just take them all away. If you end up with 2 of them exposed, take them all away. Just 1 exposed, you don't do anything. But if there's 3, there's different ways that you can play. And the way that this plays out, it says remove the 2 that will minimize the sum of the Unicode numbers of the remaining tiles. Now that's I thought this was simple, which was just take away the 2 with the higher Unicode numbers, but then the example makes clear that actually when it says minimize the sum of the Unicode numbers of the remaining tiles, it means at the end of the game. So you could have a sort of sliding doors moment where if you take these 2 away, you expose a bunch of other moves that you can play, but if you take these 2 away, then you don't expose a bunch of other moves. So these could have the higher point values to remove, but not expose other things. So you actually have to play out the whole game and then figure out which ones did best for that. So first thing, let's just naively apply the earlier version. So instead of wrap rows here, I guess I did this in the other video, I named these layers just as layer 1 and layer 2 so that I can say my starting array is going to be, so first we'll do the top layer, and that is not complete. So we'll say if layer 2, then index of all this stuff by layer 2. Otherwise blank, and index of the same thing by layer 1. And then, instead of just taking Unicode of that, we can ditch the if error because we don't need that. Actually, let's keep it. So we're going to concat all of this together and then split it into characters. So take letters of all of that and then do that. And that will match most of the answers because there aren't that many cases where where you go wrong if you just take out all the seasons if there's more than one present. But let's try and go for a full solution. So let's take equals 1 step plus edit lambda. And so what we want is way down here where we're saying if this is the sort of the case where we're in the Unicode is less than 1,000, meaning it's a letter, meaning we're either a flower or a season. And in that case, we take the third column of the group, which has the list of tiles or the concatenated string of tiles, and we iterate through those. So in this case, if the number of things in the group is 3, then we don't want to go through all of them. We only want to go through a subset of them. So the first thing I'm going to do is add another argument here, which is I'll just call it nums. And then we're going to say, just copy all of this. No, sorry, copy all of the index bit. So we'll say if the index for the second column, which is the count of occurrences, is equal to 3, then I want mid of the list of characters by nums 1. Otherwise, I want this whole letters thing here. And then if my brackets all still balanced, that should be good. I will save lambda as. I'll call this 1 step L7. And so then I just need my 3 possible sets of numbers, which are going to be 1, 2, 1, 3, and 2, 3. So then I can say what I'm interested in is, well, first we'll do the by row of this lambda row. And then here, instead of one step plus, we'll say lambda AV 1 step L7 of A and row. So the row from the by row here being the numbers that we keep. So close, close there, then close, close here, and that will return 3 different numbers, and I'm interested in the lowest score out of all of those. And that should work for, no, that does not work for that, or any of these. What? What? Bother, I've done something wrong. Okay. All right, let's take the inner reduce, which should give me my ending grid. You're not happy with that. Okay. Oh, yeah, because I haven't defined row, but fine. Let's do 1, 2. That does something. So why isn't this working then? So on some if error Unicode letters concat of all that. So concat doesn't need anything, the letters doesn't need anything, the Unicode doesn't need anything, the if error needs a 0, and the sum. So that works. Okay. If I do 1, 3, that works. And if I do 2, 3, that works. So what? I don't get it. What's the problem? Oh, it's because I didn't lock the bloody thing. Ugh, stupid. You do all these grand, highfalutin things, and then you forget to lock cells, and it breaks. All right, there we go. Yeah, that's not the elegant, drop a cherry on top finish I was hoping for, to just clown around and forget to lock cells. It could have even just hard-coded that. There's no need for that to be its own thing. But anyway, all right. Got there eventually. Yeah, I think I dodged a bullet by not being on stage for this semi-final, because that would definitely have broken my run of perfect scores with a little bit of time to spare. But yeah, there you go. That's all I got for today. Thanks for watching. See you next time.